welcome to week 2. We're going to cover chapter 2 this time around, and again, this is going to be a highlight of a chapter in the textbook. This time it's chapter 2, Behavioral Analysis of Drug Effects. The first several pages of chapter 2 go through a brief history of behavioral pharmacology. Both pharmacologists and psychologists had been doing research on the effect of drugs on the central nervous system and on behavior, but the specific field of behavioral pharmacology, kind of combining those two different viewpoints, really developed in the 1950s with a couple of key events that happened. One was development of chlorpromazine, an antipsychotic drug. All of a sudden, rather than just institutionalizing patients, there was a treatment for it, so pharmaceutical companies got involved. There was a need for more drugs to be developed. Another was operant analysis and operant techniques, and that was first demonstrated by Dews, and you can see figure 2-1 for more on that. And then the third event was kind of understanding how physiology affected behavior, and that was really pioneered by Brady. All of those things led to the founding of the Behavioral Pharmacology Society. That happened in 1956, 1957, and the field has grown from there. To rigorously study the effects of a drug, controlled experiments are designed. So an independent variable is the variable that's manipulated. For our purposes, it'll be a drug dosage or the type of drug or the way the drug is administered, something along those lines. Then the dependent variable is what is observed, or the behavior, for our purposes. And researchers need to be able to define that precisely. How will the behavior be measured? Controlling an experiment means keeping everything as identical as possible except for the independent variable. So again, that's the drug itself. The book goes through an example of studying the effect of THC on laughter and points out that to be able to claim that THC increases laughter, you'd need to have a no THC control to compare the results. Experiments with within subject controls use individual subjects as their own controls. They observe the same people without and then with a drug. And then between subject just means that different people are observed, some with, some without the drug, and then enough subjects are needed to average out individual differences with a between subject design. A placebo is just an identical pill or injection or whatever the administration is with no active drug in it. So it's a sugar pill generally. This is to control for placebo effects, which are if subjects take a placebo, their behavior might change because they expected a drug to be affecting them. That is, a subject's expectations can have a big effect on their behavior. And the book gives examples of this with caffeine and pain relievers. Three-group design means that a new drug is compared with placebo. That's to be able to show any effect. And then the drug is also compared with an established drug to be able to show an improvement over standard treatment. Then another point here is experimental bias, where if a researcher knows who got the drugs and who got a placebo, they might not be as objective in observing data, or they might see what they expect to see. So experiments are blinded, and double blinding just means that neither the subjects nor the researchers know whether placebo or drug A or drug B was administered. Non-experimental research is observing relationships rather than demonstrating cause and effect, and the book gives a couple examples, or one example, smoking and infant mortality, of where non-experimental research is used rather than these types of controlled experiments. In classical conditioning, we need to understand stimulus and response. So an unconditioned stimulus is a natural or reflexive stimulus. With Pavlov's experiments, this is the food. And when they were given food, the dogs salivate, and that's a natural response to food, so that is the unconditioned response. Then, by ringing the bell when serving the food, the sound of the bell became the conditioned stimulus. The dogs started to associate the sound of the bell with the food. And eventually the food was removed, but the dogs would still salivate at the sound of the bell in the absence of the food, which then is the conditioned response. So an operant behavior is, in contrast to a reflexive or natural behavior, it's a learned and voluntary behavior. The example of this in the book is a dog begging. And that operant behavior is learned through reinforcement. The dog gets food when it begs. That's why it's begging. There's different types of reinforcement. A reinforcement is a consequence that increases the likelihood of that behavior. So a positive reinforcement is easy to understand. It's a reward. It's the presence of a consequence that's increasing a behavior. Negative reinforcement is a little bit trickier to understand. So this is removing a consequence to increase a behavior. This is not the same as a punishment, which is a consequence that's intended to decrease the likelihood of that behavior. So let's talk a little bit more about a negative reinforcement. Say my toddler doesn't like to eat vegetables, and he complains about vegetables being in front of him at dinner time. When he complains about vegetables, if I remove them, then I'm negatively reinforcing his behavior of complaining, of screaming, of throwing, of whatever. The carrots sitting there in front of him are this negative consequence, and removing that negative consequence reinforces his bad behavior. You're hitting the snooze button removes an annoying sound, so that reinforces the behavior of hitting the snooze button. This can be avoiding or removing a negative consequence. So the dinging in your car until you buckle your seatbelt, it's trying to negatively reinforce your buckling up by removing that negative consequence, that annoying sound. So again, punishment is a consequence that decreases a behavior. And to tell a negative reinforcement from a punishment, they can be kind of two sides of the same coin. But the basic question is, are you trying to increase a behavior or decrease a behavior? Am I trying to increase my toddler's eating carrots, or am I trying to decrease his complaining about the carrots? I'm probably trying to do both, but that's really the heart of the question. An interesting point here about addiction is that using drugs, drug use can be both positively and negatively reinforced. Maybe your high after using a drug is the positive reinforcement, but using a drug can also remove fear or anxiety or guilt temporarily. It can provide an escape and remove those negative emotions, and therefore be negatively enforced as well. So you can think about this for all different types of behaviors in your life, or if you're a parent in your children's lives. Functional behaviors and dysfunctional. What's the behavior? What is reinforcing that behavior? So reinforcement schedules are just when the reinforcements are delivered, the pattern that determines how the reinforcements are given. These can be done either on a ratio schedule or an interval schedule, and different patterns produce different results. But for now, we're just going to talk about ratio schedules versus interval schedules. Ratio schedules are after a certain number of responses, the reinforcement is given. So a fixed ratio, maybe every 10 times the rat pushes the lever, the food pellets deliver, something like that. There's a fixed number, and after that number is reached, the rat gets the lever. The variable ratio means that that number changes every time. Sometimes it's every 3 times, and sometimes it's every 20. But the book points out that you can have a variable ratio 30 schedule that would it would reinforce on an average every 30 responses. Then an interval schedule, rather than being based on the number of responses, it's based on a certain amount of time. A fixed interval is after a certain number of minutes or whatever, say after 5 minutes, if at least 5 minutes have passed, then the behavior will produce a response. And then similarly, a variable interval means that number changes all the time. So sometimes you have to wait 2 minutes, and sometimes you have to wait 20 minutes. But again, as the book points out, a variable interval 2 means that the interval is on average 2 minutes long. Dissociation is also known as state-dependent learning, where behaviors that are learned in a drug state are dissociated from the undrugged state. The example in the book is that drug rats who learned to avoid a shock, that learning did not carry over to when they were given placebo. and vice versa as well. When they were given placebo and they learned something, that didn't necessarily translate to learning it when they were under the influence. But then drugs can also be discriminative stimuli where they can learn if you're drugged, go left to avoid the shock or to get the reward or whatever it is. If I'm not drugged, go to the right to get the same reward. Basically, they could learn that drugs could act as discriminatory stimulus. Um, and in fact, the lab animals can discriminate between a drug and a placebo, different doses of drugs, and different drugs. And then drugs can also be reinforcers, as I mentioned a little while ago. This has to do with their abuse liability. Basically, the idea is that if a drug is more positively reinforcing, then there's a greater potential for abuse. And there's different ways to measure how reinforcing a drug is. One is the rate of responding. So the idea here is that more reinforcing rewards would lead to a faster response. And the example in the book is a rat will push a lever quicker for 3 pellets than it will for 1 pellet. But the caveat or the warning here with drugs is that there's an effect of drugs, and sometimes a drug might put you to sleep. So even if it is highly reinforcing, you won't be able to get more of it soon because you're asleep. Then there's a progressive ratio schedule where the fixed ratio increases. It takes more and more behaviors for that reinforcement. Maybe at first you only have to do the behavior 3 times for the response, but then you need to go up to 5 and 10 and 15 and 20. There will be a breaking point where the organism, the rat or whatever you're testing, doesn't respond further. And the idea there is that more reinforcing, more positive or stronger drugs would have a higher break point, so they're more likely to abuse those drugs. Another way to measure this is choice. Basically, first the rat has to press lever A to get drug A. Then the rat learns they have to press lever B to get drug B. And now each lever is giving its respective drug. See which one the animal chooses. And then the final way to measure this that is discussed in the book is a conditioned place preference. You can condition an animal to have a place preference. So in one area of the box, give the drug, and the rat can feel the effects of the drug. Now in the other area of the box, give the placebo. The rat feels the effects of the placebo. And now remove the barrier and see which side the rat prefers. It typically prefers the area where it was more pleasurable. So, and you can also measure the amount of time they spend in the different places. So the strength of their preference is going to give an idea of, again, it's a way to measure how reinforcing that drug is. And again, that relates to how likely it is to be abused or its potential for abuse. And just a note here, places can also trigger responses in people. So this is relevant to humans. If a place is associated with getting high or negative emotions or something like that, a place, a situation, or a specific place can be a trigger. So there's lots of different ways that we can measure behavior in humans and how that behavior is affected by drugs. The first one the book talks about is very subjective. It's called introspection. It's asking someone, how does this make you feel? In an unstructured introspection is just open-ended like that. It's self-reported, and you're asking a subject to report their experiences. So that can be, again, subjective, but it's hard to quantify that. So a more systematic or quantitative way to use introspection is to use different rating scales. And the book talks about the visual analog scale, the profile of mood states, the Addiction Research Center inventory. And there's lots of different scales that have been developed to be more quantitative and more systematic about introspection. Rather than asking someone, are you happy right now? You can give them a scale of 1 to 10 and then report, this drug lifted mood from an average of 6.3 to an average of 8.8 or whatever the case may be. Another method is drug state discrimination. So subjects learn what the drug feels like, learn what placebo feels like, and then you ask them to discriminate. You don't tell them you're getting placebo right now, but you administer either drug or placebo and ask them which one did we give you. And as we talked about a little bit ago with rats, humans can discriminate between drugs and placebo and between different drugs as well. And the book says it's similar to laboratory animals. You don't really see a difference between species, among species. You can measure how a drug affects the perception. The absolute threshold is the level of a stimulus needed to sense anything. How bright does the light need to be for me to see it? Or how loud does the sound need to be for me to hear it? That kind of thing. And then the difference threshold is how big of a difference do you need to see a change? That can be the level of the stimulus or the location of the stimulus or a change in pitch or what have you. And then again, measure those thresholds with and without drugs is what you would be interested in our case. Motor performance, we all know that drugs can affect our motor skills, so you can see how drugs affect different measurements. The simple reaction time is just responding to a stimulus in a simple way. You push a button, for example. A complex reaction time is choosing different responses. Maybe there's different buttons to push. Or an example would be, we all know we're not supposed to drink and drive because it can slow down our reflexes and diminish our motor performance. So a simple thing would be stepping on the brake when you see the car in front of you, when you see their brake lights come on. But more complex would be choosing whether to swerve or stop, or if you're driving under normal conditions, choosing to put on your turn signal and turn the car, that kind of thing. A pursuit rotor is also an example the book gives of a way to measure motor performance, and there's other motor tests as well. So you can also measure attention and vigilance, how attention and how vigilance are affected by drugs. The book gives an example of using a Mackworth clock test where the participant has to notice if a clock skips 2 steps instead of 1 step. Memory can be affected by drug use. You can test short-term memory with what the book describes. The in-back test is one way. Long-term memories come from short-term memories through consolidation and recall. So implicit or procedural memory is how to do something, how to ride a bike. Explicit or declarative memory is recall, what the name of the bike is or the fact of where your bike is located, something like that. And then one type of explicit memory is episodic memory, where you can recall events or tell a story. And there's different tests for that as well. The book talks about free recall and cued recall tests. Response inhibition is just testing a subject's inhibition or impulse control. And again, it's of interest to do that with drugs and without drugs to understand how drugs are contributing to impulse control. For a new drug to be marketed in the United States, it must first be approved by the Food and Drug Administration, or the FDA. The process for drug development is first the drug's tested in animals. It needs to just basic pharmacokinetics, pharmacodynamics need to be established so that it's shown to be safe, and also so that the dosages can be worked out, where the therapeutic doses, the ED50 or the therapeutic dosages are for animals. Then a drug can move into phase 1 testing. This is basically just to show that the drug is safe for humans to take. This is done in healthy patients generally. Then in phase 2, the drug is moved into humans who have some disorder or disease that you're trying to fix with this drug. So this is the first time that it can really show efficacy in humans. If those requirements are met, then the drug can move into phase 3, where you expand your patient population, and this is where you're going to have enough patients to be able to generate statistics and be able to say definitively you're going to compare it to a placebo or compare it to an established drug, or what have you. We talked about the three-group design of research earlier. At that point, the FDA the drug can be submitted for FDA approval. If it's approved, it can be marketed. But the research on the drug likely goes on. Phase 4 is post-marketing, post-approval tests where you can gather long-term data. You also have a lot more patients taking the drug, so you can collect more data on rare side effects or what have you. The only other point here is that off-label use is a use that's not specified in the initial approval, and the book goes through a few examples of drugs that were used off-label initially that were later approved for those other indications.